All right, so today we're going to talk about the law of cosines. We did the law of sines yesterday. So you've got these three formulas right here. You need to you don't have to memorize all six. You choose either the left side or the right side, the standard form or the alternative form. It doesn't matter whichever one makes sense to you. But if you look at them, doesn't this look an awful lot like the Pythagorean's theorem, right? And so all of the lowercase letters are your side lengths, and the uppercase letter is your angle. So notice that if I'm finding side A, it's squared on one side by itself. Everything else is on the other side. So what sides are missing from A? B and C. And then you do have to remember the part that it's minus 2 times something. Well, what's the something? If I'm finding angle A, notice that I'm finding the same angle as the side that's on, by itself. And then these two are the missing from the A. So I've got the sides BC and A, so they kind of go together a little bit. So you can kind of look at that pattern and see. You can choose to memorize this pattern or that pattern. I'll use both patterns so that you can decide which pattern you like best. If I'm finding a side length, you're going to see me today using this. And by finding an angle, you'll see me using this. Question? What about, okay, I know, I'm going to do that later. I told you that. All right, so number one, we're going to look at when do we use law of cosines. So law of cosines is used specifically when you have SSS, all three sides and no angles, or SAS, you have two sides and the included angle. So remember, yesterday we had two sides and an angle, but it wasn't the included angle. For law of sines, you have to have an angle and the side opposite it. So it will never be the included angle if you have the angle and the side opposite it. So yesterday it was SSA, the bad word spelled backwards, but cosine is good. It's got SAS and SSS. So you can either write that down over here if you want to double emphasize it. So there's two cases. You have all sides, all three sides, SSS. So you'd have some triangle, acute or obtuse. You'd have A, B, and C. No interior angles whatsoever. Or your second situation would be two sides, and not just any angle, but the included angle. And so that might look like this, where this is the angle in question, and we'll call that angle B as a boy. And so that means that this would be side A and side C. In other words, I don't have this side opposite that angle. So then let's look at the situation we have here. You were to solve the triangle. What do they want when they say solve the triangle? All six parts, right? So you've been given 3 out of the 6. When you answer these questions on your test, make sure you give all 6 parts, not just the 3 that are missing. You don't want to lose points because those are like free points being given to you. So I've got all 3 sides. So if I have all 3 sides and I'm trying to find an angle, I'm going to use here for you this formula here just because it's the angle in question. Now I will only use law of cosines once. Then I will immediately revert to law of sines because law of sines is easier. The formulas are easier to memorize, aren't they? Okay, that's why. And then in this case, once I get one angle, if I use the law of sines, then to get the second angle, can I just subtract those 2 angles from 180 to find the third angle? So that's kind of my strategy. So step number 1, how do I know which angle I should be looking for? Because they've given me side A, B, and C. So it's a good idea to find the angle. I'm going to write a lot of extra notes today that I normally won't write, only because when you go home, you're going to go, why did we decide to do this first? So it's a good idea to find the angle opposite the longest side. Why? Why might that be a good idea? That'll be my biggest angle, so then what would I know about my other angles? They should all be smaller, so they'll at least give me some idea. Whereas if I start in the middle, you know, I may or may not have something as easy to compare to. All right, so step one. Since my largest side is 26, I'm going to find angle C. So I'm going to use this formula right here. So the cosine of C is equal to, and again, if you look at the pattern, it looks like Pythagorean, you know, all of the sides are squared up here, but the side that belongs to the angle I'm trying to find is being subtracted. And then below this, I've got 2 times A and B. A and B are the two sides that are not associated with the angle that I'm trying to find, so that might be a helpful way to memorize it. I like memorizing this. Well, I guess either way is just as easy. It just depends on how you look. To me, this is easier to memorize, but that's me. So I've got A squared plus B squared minus C squared, all divided by 2AB. I want to see the general formula. That at least ensures that you're putting the right things in the right spot. So I've got cosine. I'm going to plug in 13, and then 18 for B, and then 26 for C. And then we got 13 times 18 below along with it too. Now, can I just plug that all into my calculator? So we're going to find the decimal equivalency of this. Squared plus 18 squared minus 26 squared divided by 2 times 13 times 18. So I did get a negative, but that's okay, right? So take it out to 4 decimal places. You don't want to use 1 decimal or 2 decimal places for this. You'll have a lot of rounding error. So you either put that whole thing, you can put this whole thing in your inverse cosine, or you can just put the 4-digit decimal. It's your choice. But remember, this is approximately equal to negative 0.3910, right? But that's what the cosine of C is equal to. Don't we find C is equal to the inverse cosine of that decimal? Right? If I'm trying to find my angle, we have to use the inverse cosine. Anytime that your variable is in the degree, you're going to use inverse sine, cosine, tangent to find the answer. And so that's what I'm going to put in here. And then we're going to take our degrees out to 1 decimal place. So 113.0, and we are going to leave it as 0.0. So C is approximately equal to 113.0 degrees. If you want to go out to 2 decimal places, you could. You'll just be 0.02. Either way is fine. Now, if you go from here to here, I have no idea what you put in place for your inverse cosine. I have no way to give you partial credit because I don't know where you made the mistake. So do be careful, show all your work. All right, so I have C. What do you suggest I do now? Yeah, so now use law of sines, because now I have an angle and I have the side opposite. The minute you have an angle and the side opposite, revert to law of sines. So use law of sines. And then I'm going to use C over sine of C. And does it matter which one I go from here? You choose to find angle A or angle B. It really doesn't matter. So I'm going to choose B. I would, either that or you're gonna show that the sine of B is equal to 18 times the sine of 113.0 degrees, all divided by 26. So you either show the cross products and then how you get here, or you're gonna show that. Be careful going from here to here. I can do it because I'm pretty good at algebra. You might make a mistake. I make a mistake once in a while too. So if I make a mistake, it's even more likely that you can. So just beware. The only reason why I'm skipping it is because we don't have a lot of room. So I'm going to put that into my calculator. What do you have to make sure about on your calculator? That you are in degrees. So always double check. My degrees is lit up, so we're good to go. So remember, I haven't found my degree yet. That's my decimal equivalency. Because I don't know B, I'm going to use inverse sine. But this is approximately equal to a 4-digit decimal of 6373. So then the inverse sine of 6373 is approximately equal to, so this is what C is. Oh, I'm sorry, B. My bad. So I'm going to put that in here. Oops, sorry, I thought I did. I knew that that was going to be really wrong though, right? Pretty sure that's not my degree. So 39.6, or you can do 39.59, either way. And I do expect it to be less than what? 113, right? So I have 2 of the 3 missing parts. How do I get the third? Yeah, so then to find the measure of angle A, that's equal to 180 minus 113 plus 39. I don't know why I put 59. I'm not being consistent, so 39.6. So 27.4. Now then you want to go back and look at your angles and make sure that, which is your smallest side? A. Which of the 3 is your smallest angle? A. So, and then this is obviously our biggest and this is our middle. So it does seem like a reasonable answer. That's not so bad, right? Much better than the ambiguous case from yesterday. All right, so then look at example 2. This time you're given 2 sides and an angle. Because you're not going to be told, by the way, solve using the law of cosines. You have to figure out when do you use the law of cosines. Omar, why don't you come sit up here? It's your new seat. I'll explain why. For both of you. So how do I know that I'm using law of cosines first? Zach. How do I know that I'm using law of cosines?
Because you have side and cosine.
I have side angle side. The sides that they've given me, I don't have the angle opposite A or C. So if I don't have the angle opposite A or C, I'm automatically using law of cosines. So I'm going to draw a picture just so you can see. You could have drawn a picture on the last one. So if this is my angle B, we'll call this A and this C. So they've given this as 75 degrees. Did you run into the minutes again in your homework and not remember what to do with that? Yep. Well, yes, but 21 minutes is not. So I'll remind you on your calculator how to throw that in there. And then they also gave you that side A, so across from angle A is 6.2. And across from side C is 9.5. So we need to find side B, and we need to find this angle and this angle. So this time I have my angle. So since I have my angle, and I'm trying to find a side, I'm going to use one of these. So I'm going to switch up and just use the other side for a minute. What side do you think would be best for me to find first? Side B, why? That's the only angle you have, right? And I want side B across from it so that I can then use law of sines. My goal is to use law of sines because it's easier. So very first step, number 1, find the unknown side. In this case, it happens to be B. First, using law of cosines. Bless you. So I choose to use, since I'm finding b squared equals the other two sides, a squared and c squared, come next. And there's always subtraction there, so 2. And if you notice here, the same things I'm using here, I'm using here. So I've got AC, and then that's times the cosine. And this is always the same as the side that I'm trying to find. So plug in what you know. So can I just throw that in my calculator exactly as it looks? All right, so let's go ahead and do that. I'll try to get the glare off of there. There we go. All right, so here's how you find your degrees in minutes. So we've got 75 degrees. So you want to go into the angle app. So you have to go second function, apps, to get the angle, and see how we have degrees. Hit 1, and then for 21 seconds, 21, go back into the angle app, and then number 2 is your minutes. Now that's not our answer though, right? Because isn't that b squared? B squared is equal to 98 points, and I'm going to go out to 4 decimal places, 89.68. So that's approximate because I just rounded. So now how do you solve for b? Take the square root. So b is approximately equal to 9.9 units. So there's 1. Now what shall I do? Now we're going to switch to law of sines. So now I know that b is equal to 9.9. I have the side opposite my angle. The only problem is that I could have made a mistake, but I really don't have much choice. So step 2, use law of sines. And I'm just going to use b over sine of b is equal to, what side do you want to find? Or I'm sorry, what angle do you want to find? C? Why? We already know this is our biggest side, right? It's our biggest angle. So it really doesn't matter. You can find C or you can find A, it really doesn't matter. So we'll go with C. But shouldn't both of these be less than 75 degrees in 21 minutes? Okay, so I'm gonna find C. So those of you who just printed out my notes, they're different now because y'all chose C and I think I had B on the notes. All right, so I'm gonna plug in what I know. 9.9 over sine of B equals so cross multiply so this is going to give us a decimal equivalency. So let's throw that in the calc. So you should get 9284. So then the C is equal to the inverse sine of the 0.9284. Do we get less than B? Now, since that's in degrees and minutes, the original one, do you want to find yours in degrees and minutes? How do you do that? Second angle, so go second apse, and then see the DMS. So you want to hit 4. So now we have 68 degrees, 11 minutes, 12 point whatever seconds. So just go out to your minutes. So 68 degrees, 11 minutes. So I'm going to go backwards. I'm going to do that again. Degrees are always you can go degrees all the way out. Well, you'll never go out longer than you personally, than seconds. But it's not minutes and seconds time-wise that we think of. It's a smaller measurement of degrees.
It's divided the same way.
Yeah. Yeah.
Degree is
All I did you find it? Okay. Is everybody okay as to how I did that? Okay. So if I wanted to change this into degrees and minutes, you're going to go into second function, apps, and see the DMS. You're going to click on 4. And then you're going to see this. You're going to hit enter. And then you should come up with that. Did it work? Okay. We all set? Now, I have one more thing to find, right? Because this is only thing 2. What's my last piece? Yeah, the last piece should always be the easiest to find. And so step 3, we're finding the measure of angle B. So that's equal to 180 degrees. Am I? Yes. No. I already found B. Sorry, A. I knew I had the wrong angle. Measure of angle A. So if C is 68 degrees and 11 seconds, take 75, 21, and add 6811. So again, use your calculator. Let it do the work. So 180 minus 75 degrees, 21 seconds, plus 68 degrees, 11 seconds. So how do I convert that? What do I teach? Second apps, 4, and then enter. So 36 degrees, 28 minutes. these three. Yes.
That's whatever you want it, whatever you want it is, or-
If you're, he wants to know whether I want it in degrees and minutes or a decimal. If your original degree is in degrees and minutes, you should know that you're going to go out to minutes. If your original degree is in decimals, then you can keep it in decimals. Like this first one, you could decide whether you wanted to do degrees or minutes yourself. Most of you are going to, or decimal or degrees and minutes. Most of you are going to just go with decimal. It's easier, right? But the degrees and minutes are more accurate.
Will you ever get seconds?
You could. You know where your second button is, right? Where is it? Because it's not under the apps. Where is
It's
it?
the plus.
Yep. See right here, it's really hard to see. It's the green. It's green on mine. I don't know what color it is on yours. But it's really hard to see, but it's right above the plus. So if you did that, you'd have to go to alpha, right here, and then touch plus. So yes, you could. It's no more difficult. Okay, flip it. We have another area formula. This is Heron's area formula. You do need to learn this as well. It's not that hard to learn. It's real simple. It's a square root, right? What do you notice that's the same in the formula itself? What keeps repeating? This S. There's an S here, and an S here, and another S here. So you have to find what they're referring to as S. So to find S, all you do is add up all the sides and divide by 2. You're going to take that S, and you're going to subtract each of the sides from it, and multiply those 3 differences times S again, and then take the square root of the whole thing. That's all you do. So let's look to see what we got here. So you were to find the area of the regular or the triangular region having sides of lengths A, B, and C. How is this different than what I gave you yesterday for area? In other words, how would you know whether to use this formula or the formula I gave you yesterday? What don't you have on this one? You don't have any angles. There's your difference. If you have all sides, you're going to use Heron's formula. If you have an angle, you're going to use the formula from yesterday. So step 1, find S. So S is equal to my 3 sides, 43, 53, and 72, added together, all divided by 2. So I get 84. And then step 2, use Heron's formula, area formula. Now I do need to see your formula and you plugging into it. So area equals, because that ensures that you put the right things in the right place. Say that again? Yes. Yeah, you're not going to get a negative. I can't think of, it's impossible for S not to be bigger than any of your one sides. You get a negative, yeah. And you can put this exactly as it looks right in your calculator. I mean, don't bother to do all that math. I mean, let your calculator do some work for you, but you're at least telling you what you're putting into it, right? And so the area is equal to 1,131.5 either 9 or 89. What's the unit of measure? But it's squared because it's area. Now, how would you know that? Well, this is going to end up being meters, right? Because all of this is meters. Divided by 2, won't that give you meters? So if this is meters, this is going to end up being meters, this is going to be meters, and this is going to be meters. What's m times m times m times m? M to the 4th. What's the square root of m to the 4th? M squared. So if you put your meters in there, you can't avoid not knowing what the exponent is. Danny?
Oh, so it's not always one square.
Well, it could be, it's always squared, because area is always unit squares, but it could be inches or, you know, right? Joy? Quiz, yes. Test, no. Notes on your quiz is yes. When you now your test, the good news about your test is if you've noticed, your test is split up into 2 different tests. I test you one day on 6-1 through 6-3, and then the next day on 6-4 to 6-5. So you'll concentrate on studying for half of the test one night and the other half the other night. Yes? How many? If I don't tell you it's always 1 or 2, I'm satisfied with 1 or 2. You know, unless the directions are specific otherwise.